everybody, Sir Beaton here, and welcome back to another past paper practice video. In this video, I will be looking at a distance time graph question. So let's not waste any time, let's head straight into this video. So this question says, the velocity time graph below describes the journey of a car over a period of 70 seconds. The journey was represented in 5 stages labeled 1 to 5. So the velocity time graph will tell you how a vehicle or how something move in terms of their velocity over a period of time. So they will accelerate, they will go constant, probably accelerate again and then decelerate and then come to rest, which means they will stop. So let's go. So it says complete the following statement. During stage 4, the car is traveling at, so let's look at stage 4. So this is stage 4. So the car is traveling at, so on this side we have velocity, and on this side we have the time. So they want the velocity at stage 4, so the velocity is constant. So we see that the car is traveling here. So if here is 40, here is 50. Of course, here would be 45. So the car is traveling at 45 meters per second with an acceleration of, let's go back to the diagram. So we see the car is neither accelerating nor decelerating. It's moving at a constant speed, so that means the acceleration would be, and also the line is horizontal. So the acceleration would be 0 meters per second. So 2 marks, nice and easy 2 marks. So the next question says, determine the maximum acceleration of the car during the journey, 70 seconds. So let's see, the maximum acceleration would be, so in order for us to calculate acceleration of each stage of the journey, is just to simply find the gradient of the line of the acceleration, the gradient of this line here. That is how we find acceleration. So it's a rise, over run. So for the first leg of the journey, let's calculate the acceleration. So it's rise over run. So we see we rise up 20 times. So it's 20 divided by, and we see we run across. So we're counting in 5, so it will be 5, 10, 15. So 20 divided by 15, which will give us 1.33 meters per second. So this would be for the first leg of the journey. And for the second part of the journey, we see the acceleration is 0 meters per second. So let's look at the third leg. So for the third leg, we see the rise is, so we see we start from 20 and we go all the way up to 45. So we start from 20 and go all the way up to 45. So this is 45 subtract 20 would give me 25. So the rise is 25 over, and we see we move from here and we go to here. So we're counting in 5s. So 5, 10. So 25 divided by 10. So this will be 2.5 meters per second. And this will be for the third leg of the journey. So for the fourth leg, we see it's accelerating at 0 meters per second. And then for the final leg, we see that it's no longer accelerating, but it's decelerating. So we see from here to here would be 45. So it will be 45 divided by, and we see we jump back 5, 10, 15, 20. 45 divided by negative 20, since we're going in that direction. So 45 divided by negative 20 would give us a negative 2.25 meters per second. So this one is out because this is not a maximum. This is going down, it's decelerating. That is why it's a negative, because it indicates that it's slowing down until it reaches at rest, or in other words, until it stops. So the maximum acceleration during the 70 seconds would be 2.5 meters per second. So 2.5 meters per second, and this would be our working. These here would be our working. So you put your work in this space and you get your full 2 marks. Next question says, calculate the distance traveled by the car for the first 25 seconds of its journey. So you want to calculate the distance traveled for the first 25 seconds. So let me erase everything that is going on here in this diagram. So the first 25 seconds would be here to here. So in order for us to calculate the distance, so let me draw a line down. In order for us to calculate the distance, we find the area. We find the area of the shape formed. So the first 25 seconds, we see a trapezium is formed. So we find the area of that trapezium. So let me erase this piece here so we can find the area of the trapezium. So let's put in some measurement. So from here to here would be 25. And from here to here would be 10. And the height would be 20. So the area of the trapezium would be half the sum of the parallel sides, a plus b, multiplied by the height. So this would be half multiplied by the parallel side, which is 10 plus 25, multiplied by the height, which is 20. So this would be half multiplied by 10 plus 25 would be 35, multiplied by 20. And if I punch all this in my calculator, 35 multiplied by 20 would give me 700, divided by 2 would give me 350. So since we're dealing with distance, we can say the car for the first 25 seconds, the car traveled 350 meters. So that would answer the question with the calculation, 350 meters. So we can say therefore, the car traveled 350 meters for the first 25 seconds. And with that, this has brought me to the end of this video on the velocity time graph. As you can see, the concepts are very simple, but I want you to practice questions like these so that you can get a hang of it, so you can test yourself to see if you truly understand it. So with that, I'll see you in the next video. Keep practicing and take care.